percents. Yeah, percents. So I'll write it down for you guys. Percents, scientific notation, scientific notation, and counting principle. So I'll break up the parts. I know I owe you guys quite a few sections, so this video will be on these 3 sections. The problem is that the handout that I gave you guys, it belongs to a book. So what I literally did was rip off the pages and then make copies, and that's how you guys have the sheets that you have. I tried scanning this, but because I ripped the pages from the book, it kept getting jammed and jammed and jammed. And I, trust me, I tried. So I have, and some of them got stuck, got jammed, and the paper, when I pulled them out of the printer, ripped a little bit more, so it kept getting worse. So unfortunately, that means that for the video, you won't see the questions, like the actual, but I'll write the numbers down. Okay, so again, we're doing these 3 sections, and I'll start with the percent section. If I find it, which it's on page 169. So I'm going to take that. So I'll put, right, so we'll do the percent sections, and we'll number 1. So percent, which of the following is equivalent to 1/3? So 1/3 of 35%. So I'll write of 924. So I'm going to have the luxury of cheating and using a calculator. So I'm going to change 1/3 of 0.35 times 924. Can I simplify? Well, you can change this. So if it's even better, you can change this to 35/100 times 924. Can we simplify a few things? 9 and 6 is 15, so it's definitely divisible by 3, right? So this is going to be 308. But the question itself doesn't ask for the final answer. So let's see. We have choice 35% 308. No. Well, yeah, right? Because right there, if I stop over here, 35/100 is 35% of 308, which makes my choice A. Okay. 2, green is the favorite color of how many students at regional high school? Let's see, there's 3,000 students, and according to the pie chart here, green is 35%, 35/100 if you, whichever way you went. So, and then we're going to take that and multiply that by 3,000. We can take 2 zeros away, 2 zeros away, and we just simply end up multiplying 35 times 0 times 30, 15, and there's our answer, which is F. 3. Oops. All these sheets in front of you. 3. In a class of 30, there are 12 boys. What percentage? So again, question 3. In a class of 30, 12 are boys. What percentage of the class is girls? So if 12 out of 30 are boys, that means 18 out of 30 are girls, right? So let's simplify. Divided by 6 is 3. Divided by 6 is 5. 3/5, and 3/5 we know it's 0.6 or 60%, which gives answer choice D. 4. There are 20 pencils in the case, and 75 are sharpened. What percent of the pencils are not sharpened? So if 75 are sharpened, that means 125 are not. Okay, so again, we can divide by 25, which is 5 times here, and 25 goes here. 5 out of 8, and 5 out of 8 is, I'm pretty sure it's G, 62.5%. Okay, so the final answer is G, and you would have to divide 5 divided by 8, right, and then that would leave you to 0.625. 5. What percent of the student body owns 1% of the game? Okay, hang on a second. One owns one video game. So number of students, hang on a second. So let's add them up. So let's find the total number of students. So in order to find the total number of students, I would add these. So 0.5x. Let's see, 1, 2, 3, 4. Am I missing one? That's 2. 1.5x. Apologies. This is 2, 4, and then the total is 8x. So out of the 8, which is the total student population, so we know that x number of students on one video game, so it would be x over 8x, right? The percent of that owns one video games over the total number of students. We can simplify this and we get 1 over 8. And over 1 over 8 is a very, very small number, and that would have to be not very small number, right? So 1, that would be 12.5. So 0, 1, 2, 5, or 12.5%, right? Which makes this B. All right, 6. This page over. Census taker, there's 1,000 people. Each person's age represented by X. How many people live in the apartment are under the age of 35? Under the age of 35, if you look at it, it would be, so we have 4 circles, and it's sort of divided like this. 1, 2, 1, 2, right? So under 35 would be these guys over here. They're under 18. These guys up here, which is 18 and 35, but not these guys over here. No and no. So that would be 45%. Right, 45% of 1,000 equals 450. So the answer to this one would be 6, would be G. 7, we have a Venn diagram. What percent of students study French? So there are, and if you have your Venn diagram, right, we have 6 students here, 6 over here, 8 in the center, and 5. The total number of students is 6, 20, 25 is the total. And the percent, and the number of students who study French are these, the 8 and 5, so that's 13. So it would be 13 out of 25. Easier way to change to something over 100 is multiply by 4 and multiply this by 4. We get 52%, which makes this answer C. 8. Table below shows the percent distribution of the schools. How many students own at least 2 pets? Would be at least 2 would be the 2 or more. So 2 pets we have 25%. 3 pets we have 8%, and 4 or more, right, greater than or equal to 4 is 2%. So those are the 3 you would have to add, and we get 10. We get 35%, and then how many people are there? 35% of 2,400, so it would be 35 over 100 times 2,400. You can multiply it as a fraction or as a decimal. It's really up to you. So cross out these two. You should end up doing 35 times 24, 22, 14, 10 goes 1, 7. So this looks like 840, which is H. Okay. 9. Surveys show that between 20 and 30% of go to master's degree. There's 4,000 students. What is the minimum number of graduates who will not continue to a master's degree? Is that what it says? Okay. So if 20, oh shoot, man, I need to charge battery. Please run down. Stay. Sorry, folks. Okay, save by the bell. So if 20 to 30%, 20 to 30% pursue pursue, right? That means that's 70 to 80%, right? Will not pursue. Pursue. So the minimum that will not go on to get a master's would be 70%, right? So the minimum. We have a total number of students. So multiply that by 4,000, and again, you can just do 0.7 times 4,000, so probably the easier way. Times 4,000, and it's something with 28, right? Because 7 times 4,000, 0.7, 7 times 4,000. So that gives us the answer is C. Okay. 10, it rained 40% of the 365 last year. How many more days did it rain, did not rain? So let's take 40%, multiply that by 365, and we'll find out the days it rained. Throw 365 times 0.4, 20, 26, 14, that's 1460 days that it rained. Sorry, move the decimal one, 146 it rained, which means we have to subtract that. So we get 5, 15 and 6 is 9, 1, and 2 minus 1 is 219. So 10 is H. No, it's not. How many more days did it rain? Then not rain. So hang on a second. So it rained 219 days. I apologize. And it, sorry. So it rained for this many days, and it didn't rain. And it didn't rain in 219. So how many more it didn't rain? So these are the two we have to subtract, and we get our answer of 73, and that's the final answer. F. Gotta read that carefully. High school election, 1,000 votes were cast, and they were all cast for either Jillian or Clive. Jillian received 100 more votes than Clive. What percent of votes were for Jillian? So Clive, we don't know. So this is number 11. Okay. That's how many votes he's got. So we know that Jillian, so if we assume that Clive got X, Jillian got 100 more. Right, so we'll call it X plus 100. Okay, so we know now that the number of votes that Clive got plus the number of votes that Jillian got equals 1,000. We can go 2x plus 100 equals 1,000. 2x, sorry, 1,000 equals 900. And x equals, we divide both sides by 2, it's 450. So that means that Clive got 450, which means Gillian got 550. So the percentage for Gillian was B, 55%. 12. Where is it? 12. He recycled total 600 bottles. Bruce recycled twice as many as Betty, so I'll write 2B. What percent of 600 bottles did Bruce recycle? So Betty, oops, sorry, they both start with B. I'm actually going to write Bruce. It's 2 times Betty. And Betty is just Betty. All right, so you know what? Let's call Betty X. Which means that I have to, instead of 2 Betty, I'm going to write 2X. Okay, so now we can set up again that equation, right? It's a very similar problem. 2x plus x equals 600. 3x equals 600. Divide both sides by 3, and x equals 200. So Betty is 200, and Bruce is twice that. So 2 times 200 is 400. What percent of the 600 bottles did Bruce recycle? Bruce recycled 400 out of 600, which becomes 2/3. Is there a 66 point? Yeah. So 12. This is number 12, by the way. Sorry, is G. 13. Rectangle is 50 long and 40 wide. So 50 long and 40 wide. The length is decreased by 40%. So 50 long. The length, so we now have a, let me make this, sorry, so let's make this bigger. 50 and 40. Now the length is going to get smaller. So it's going to be decreased by 40%. If it's decreased by 40%, that means the size of it is now 0.6 times 60% is what we have at the end, right? And the width is increased by 20. So 40, if it's increased by 20 and you want to find the actual length, right? You multiply it by 120, 1.2. Okay, what is the percent increase in the area? Just multiply 0.6 and 1.2, that's a 12, and this is a 6. We get 6, 7. I'm multiplying something wrong. You know what? What I can do is actually find the measurements. So 50 times 40, I apologize, 50 times 40 is 2,000, right? Square units. This one, if I multiply 50 times 0.6, 40% reduction, which means we're left with 60%. So this is 0, this is 30. That means that the new length is 30, and the width here is increased by 20%, or we multiply by 1.2. That's a 0, that's an 8, that's a 40, so that becomes 48. I need to multiply, sorry. So that becomes 48. So now the new area here is 48 times 30. 0, 24 goes to 1440. Okay. And we want to know, actually that's not even the answer, what is the percent of decrease? So we can do percent of change, right? New minus old over old. So the percent of change could be, that could be, the new is 40, it's 1440. Minus the old, which was 2000, over 2000. Right, and then we change this to x, percent of change. If you cross multiply, we get 2000x. This becomes 560, right? We divide both sides by 2000. And the percent of change is going to be 560 over 2000. Let me look at the multiple choice. And it's about 1/4, right? So we're looking at, so think about it, 500 over 2000, right? Would be 5 over 20. 5 over 20, which is 1/4 or 20%. But this is a little bit more. It's 560 over 2000. So even without simplifying, I mean, you could take a second and do this. 560 divided by 20, but obviously the only choice that's going to give us is going to be D, because we know it's not C. Okay. 14. The price of a laptop was first increased, so here's a laptop by 10%, and then a new price was decreased by 20. What the final price was, what percent of the initial? Okay, so here we can go X, right, the initial price of the laptop, and what happens if it was an increase by 10%, we multiply by 1.1, so that's price of the laptop after an increase, but then it was decreased by 20%, which means we can multiply by 0.8, right? Because that's so. If we multiply that, we get 1.1. So let's just multiply that. We get 8 and 8, 0.88. So in other words, the laptop was what percent of the initial price is 88% of the initial price. Okay, so obviously it's a little bit lower than the original price. Okay, 15. Kevin watched 2 hours TV on Sunday. Erase this and write 15. Saturday will be 2 hours. On Sunday, he watched 100% as many hours of TV that he watched on Sunday, which means it's the same. How many hours of TV did he watch on Sunday? Well, if it's the same, 100% is exactly the same as that, so it's just 2 hours. Okay. 16. A company charges a 15% shipping fee on orders under 50, a 12-point on orders of 50 more. How much would the company charge for shipping on an order? How much more? Ugh. Okay, so if you take 49, so a shipping order, let's figure out something that's $49 would be under 50, right? So that'd be times 0.15 because that's the shipping fee. So let's multiply. Actually, you guys multiply that. I can cheat. So the shipping would be 7.35. So anything under 50, you would pay 7.35. Not on anything. Yeah. Then shipping order of more than 50, so let's take 51, would be 12.5 or 0.125. So if you take that and multiply 51 times 0.125 equals 6.375 or $6.38. And we want to know how much more. Did I multiply this right? 51. So instead of 51, I should have used 50 or more. So I misread that. So 50 or more, $50 or more, we'll multiply by 0.125. Right, and that's going to give us 50 times 0.125. It's going to give me 6.25. So how much more is the 49 and under? 49 and under is going to be, well, $10, $1.10. So the answer is 17. If the store sold 700 smartphones other than brands A and B, how many smartphones did it sell altogether? Other than brands, okay, so if that were sold, but if their store sold 700 smartphones other than brands A, B, C, and D, other brands. So we know that the other brands, right? So there's a circle graph here, and they're saying that this is 20%, and that represents the other brands. and they're saying that 20% is equal to 700 phones. That's how I am. Okay, so we can set up a proportion, and if we say that 20% is 700 phones, right, how much would everything else be? 100%. So there's a relationship here. We can, it's times 35. So we're going to multiply this, or you can cross multiply, it's okay. Right, times 35, and this one would be 3,500. So everything else, the total is 3,500. Yeah, so how many smartphones did he sell together? So the answer is D, 3,500. 18, John ran 8 miles on Tuesday. So let me write down. So Tuesday is 8 miles. On Wednesday was 150% of, so 150% of Tuesday, which is of 8. So I'm going to take that and multiply that right away. So 1.5 of 8 is going to be 12. Right, so on Tuesday he ran 12. How much did he run on Wednesday? Well, there we go. 18 is 12. Oh, so he ran. Sorry, no, it's not. I forget. So how far did he run to? So if so on the total on Wednesday, okay, would be that one plus this, which would be 20. Okay, 19. X is 80% of y, y is 20% of 100. What is the value of x? So x equals 80% of y equals 0.20 of 100. Right, so let me just simplify. So 0.20 over 100 is going to be 20. Right, so now we know y is 20. We can come back to the original equation and go 0.8 times 20. Okay, and 0.20, 0.8 times 20 is 16. So 19 is a 20. Fermium 25253 decays at a rate of 50% every 3 days. How much will some amount of fermium decrease after 9 days? Okay, so we have 9 days. So if you have this much, in 9 days, it's going to decrease by 50% once. It's going to be 50 twice. Sorry, 90%, right? And then it's going to decrease by 50% 3 times. So we gotta multiply by 50%, 50% 3 times after 9 days. So x times, and I'll write it at 0.5 times 0.5 times 0.5. Let's see what that is. So it's going to be 0 times 0.125. So after 9 days, we're going to multiply by this, right? This is the amount of decrease that's going to happen. So the decrease is going to be 12.5%. And we want to know how much left over. Well, if the decrease is going to be 12.5%, let's subtract that from 12.5, which means we're going to have, well, that's a 5. 10 minus 2 is 8. That's a 9. So we're going to have this much, 88.5 of the original left over. Okay. Sorry, guys. Page over, yeah, 21. Certain savings account increases in such a way that amount in the account at the end of the month is 10% more than the amount at the beginning of the month. What percent of the original amount is there in the account after 2 months? So, a certain amount. I hate when they say that. A certain savings account increases. So let's say we have, I don't know, 50 bucks. Right? So if it increases by 10%, right, so multiply. So at the end of the first month, let's see, 50 times 1.10, we would have 55 after the first month. And the second month, it's going to increase by another 10%, right? 55 times 1.0, and you're going to end up having 60.5 at the end of the second month. This is 21, by the way. Okay, so what percent of the original amount is there in the account after 2 months? So we can do a new minus O. Let's see. The new one's 60.5. The old was 50 over 60.5. And again, this I can change it to x. So we get 60.5 x equals 5.5. Divide both sides by 60.5. And x equals I subtracted wrong. This is 10.5. Apologies. 10.5. So 10.5 divided by 60.5. No, I'm not getting the answer. Hang on a second. Percent of the original amount. Alright, so if I can, let me change this. Oh no, let me erase everything. Sorry guys. No, that's fine. I can erase this. So after 2 months you have this. So 60.5 is what percent of the original amount? Let's put it that way. So 60.5. What percent of the original amount, which is 50? So is this equal x of 50? If we divide both sides by 50, right, so we get 60.5 divided by 50, we get 1.21, and that's what I want. which equals 121%. Okay, tricky. Sorry, guys. Okay, so, and then, hey, okay, so Douglaston I can make by 3. Too late, right? Okay, alright, okay, it's all good. Alright, we can do something. I'll look at the weather again. Okay, alright, sounds good. No, no, of course, but I mean, given the time constraint tomorrow, those are the only done. All right, I'll talk to you then. All right, bye. Sorry. 22. She signed up for camp, which cost 1,200. 30% was due at sign up. Of the remaining 75% was due the week before. The rest was due on the first day of camp. How much was due on the first day of camp? Oh my God! So 1,200 was due. 30% was due. So which let's multiply by 0.7, and that's gonna tell us. So she pays us 30%. You multiply that by 0.7 and 840. So this is how much she has left. So 840, which is the remaining balance, 75% was due, which means 25% is going to be left over, right? So let's figure out. So she pays her 75% of 840. So 840 times 0.25. So that means now, after paying 75%, she has $210 left over. Well, yeah, that's it. 210. So 22 is E. Okay. 23. Farmer's planning on picking, peppers. After picking the first 600, he finds that 70% of them are green. So he picks 600 times 70%, right, or 0.7. That means 420 are green. Okay. And 30% of are red, which means 180 are red. Okay, so far so good. How many of the remaining peppers he must pick must be red in order for exactly half of the total peppers picked to be red. So, well, we have how much left? We have 400 left. Okay, so if we have 400 left and he wants that at the end he has the same amount of picking in order to be exactly half the total numbers of peppers picked to be red. How many of the remaining peppers must pick must be red in order for exactly half of the total number of peppers picked be red. So he wants so that at the end 500 are red. So out of the 400 that are still to be picked, right? So again, he wants the red to reach the number 500. So let's just do 500 minus 180, and that's obviously 320. And the answer is C for question 23. Okay. The next section, let me go back, please. Go back to question. Next section is scientific notation. Scientific notation. Yeah. So scientific notation. I like scientific notation. I guess I'll find where that is. It's after absolute value, absolute context. No. Word problems. Proportions. Factor multiples. Getting there. Absolute value. Scientific notation. Scientific notation is on page 184. Okay, so you know what? I'll type this in. scientific notation. Okay, I'll keep that. All right, so number, it's not a long section, is it? Number 1, write 5,000. Okay, so write 5,500. So it's going to be, so here's 51,000, right? So the decimal's over here. Let's move it 1, 2, 3, 4. So the first number is going to be, our first factor is 5.1 times 10 to the number of spaces we moved. 1, 2, 3, 4. 10 to the 4th. So the solution is A. B is, what is the value of the same thing, 0.513. We're going to move the decimal to this, right? So it becomes 5. The first factor is going to be 5.13 times 10 to the negative, how many spaces we need? 10 to the negative 1. So remember, any numbers in scientific notation, the first number has to be a number between 1 and 10. Okay, so the second one is F3. So again, 0.000, I think there's 302088. We're gonna, so again, we're moving this decimal 1, 2, 3, 4. So it's gonna be 2.088 times 10, and again, it's negative exponent, 10 to the negative 4th. All right, which makes our answer 2.08. Okay, answer is A. Okay. 4. So that was number, sorry, that number 3. Number 4. So 5. So you can multiply this out. So if you multiply, so we have 513, 700 times 1,000. You can actually multiply this out. You're just gonna increase it. You're gonna add 3 zeros because that's what happens when you multiply by 1,000. Right. So now this you can take and write it in scientific notation. Okay. And we're gonna get 5.137. Okay. And then how many? What's the number of decimal places? 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8th power. And we get letter 4 is G. 5. Oh my God, I'm having trouble with glasses. I need to get my. Again, same thing. 952.65 times 1,000. So you can always multiply that out first. So multiplying by 1,000, the shortcut is knowing that the decimal moves over 3 spaces to the right. So it's going to be 1, 2, 3. So we need another 0 here. And this you can write in what do you call scientific notation. So this is going to be, right? First factor is going to be, here's my decimal, move it 1, twice, 3, 4, 5. So it's 9.5265 times 10 to, and we moved it to the 5 spaces, so 10 to the 5th. So that is C. So even when you look at the multiple choice, I mean, even D, you shouldn't even pay attention to it, right? So E, write it. Okay, so we have 5, and we want to write it in standard form. So it's 5 times 10 to the negative 3. Here's 5. Here's my decimal. We're going to move left because negative 3, think of a small number, right? Less than 1. So we're going to go 1, 2, 3. Here's my decimal. So my number becomes 0.005, which is G. 7. Write in standard form. So 3.695 times 10 to the negative 7. So 3.695. We're going to go left, right? Because it's negative. 1, 2, 3, 4, 5, 6, 7. So my new number. Geez, can I see this? 1, 2, 3, 4, 5, 6. Which one has 6? It's going to be 1, 2, 3, 7. It's going to be B. Okay. Number 8, the distance between two cities is 4 times 10 to the third. What is the distance between in meters? Oh, that's okay. So first of all, let's change that. 4 times 10 to the third power is going to be 4 times 1,000, which is going to be 4,000 kilometers, right? So if you know 1 kilometer is 1,000 meters, so 4 kilometers is how many meters? Well, it's a times 4 relationship, so multiply that times 4. Oh, sorry. It's not 4 kilometers. Well, it still is. Well, I'll show you in a second. So my mistake was what happens when it's 4,000 kilometers. So we didn't multiply by 4, we multiplied by 4,000. So the top was by 4,000, so the bottom is going to be by 4,000. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, which gives 4 million meters, which is H. The number 8 is H. Number 9, 1 meter is represented by 1 millimeter. So 1 millimeter, 1 centimeter, okay. The building has a length of 370 meters. What is the length of the building in meters? What the heck? What? What's the length in meters? 1 meter. On the blueprint, 1 meter is represented by 1 millimeter. Okay, if the building has a length of 370 meters, what is the length of the blueprint in millimeters? Okay, there's something off with this question. It can't be. Are they really just saying 1 meter is represented by 1 millimeter? Okay. If the building has a length of 370 meters, what is the length of the blueprint in meters? Well, 370 is, okay, so you can skip this question, 3.7, sorry, 370. If we change that to scientific notation, it's going to be 3.7 times 10 to the second power. I don't, skip. 10. The distance from Earth to the Moon is approximately 2.4 times 10 to the 5th miles. Okay. The distance from Earth to Mars is approximately, so this is to the Moon. And to Mars, the distance is 6.0 times 10 to the 7 miles. How many times further is Mars? How many times further is Mars from the Moon? How many times further is Mars than the Moon from Earth? Okay, 10. So what we can do is we can take this, right, let's say 6 times, I'm going to just take the 0, times 10 to the 7th, and we can divide by 2.4 times 10 to the 5th. Okay, if you think about it, this you know how to do, 10 to the 7th, 10 to the 5th, we're left with 10 to the 2nd, right? And 6 divided by 2.4, can we change that? Well, 6 divided by 2.4, move that one over, we get 60, 24, and this one becomes 60. We get 2, we get 48, we have 12 left over. Bring a 0 down, add a decimal, and I believe that's 5, yeah. So it's 2.5 times 10 to the second. Put a little x here. So 10 is F. 10 is F. Okay. 11. What is the value of numeric expression in scientific notation? Well, 5. This is what you have, right? I mean, it's all being multiplied. So let's multiply these two, keep the base, add the exponents, and then 5 times 3 is 15. So it's 15 times 10 to the 8th, which we're going to change to, because that's not written in, what do you call, in scientific notation. So be very careful because that's scientific notation. So let's change the 15. So let's change this guy here to scientific notation. 15 scientific notation. Well, the decimal is to the right of 5, so here's 15. Move the decimal 1 over. So first factor is 1.5 times 10 to the first power. So let me rewrite that. So 15 is 1.5 times 10 to the first power, and don't forget times 10 to the 8th power. We can now combine these two or multiply those two. So 1.5 times 10 to the 9th power. A little tricky. Be careful with that one. 11. So that's 11 was C. Okay. And then 12. Did I just do 12? No, I did. Again, so 12 is the same idea. 5 times 10 to the 6 times 6 times 10 to the 4th. Well, 5 and 6 is 30. 10 is to the 6th power, 10 to the 4th power is 10 to the 10th. But notice that it's not in scientific notation. Right, so let's change this guy to scientific notation. Well, 30 is 3 times 10 to the first power, right? Because here's a decimal, so if you think about 30, the decimal is here, we move the 1 over, so the first factor is 3 times 10, and we move the decimal over 1, so it's to the first power. So it's 30 written as in scientific notation is 3 times 10 to the first power, and then don't forget the other 10 here. And now if you multiply the 10 to the first power and 10 to the 10th, we get 3 times 10 to the 11, and that's our final answer, which is not there. What did I do wrong? Did I copy it wrong? Oh, okay, so I copied it wrong. So it's 5 10 to the 4th times 6 10 to the 4th. So let me repeat everything. 5 and 6 is 30. 10 to the 4th and 10 to the 4th is 10 to the 8th. This we just showed becomes 3 times 10 to the 1st times 10 to the 8th, and then becomes 3 times 10 to the 9th. So the final answer is E. So, yeah. So just by looking at multiple choice as well, when you're doing this, you can throw G and H to the garbage right away. 13. Same thing. 3 times 10 to the 3rd times 2 times 10 to the 2nd. Again, we can take care of these two. That's 10 to the 5th times, and 3 times 2 is 6. Yeah, that's it. This one's 6. This is already written scientific notation. So great. So this is 13 is A. Okay. 14. What is a sum? Okay, a little different here. So 9.5 times 10 to the 5th plus 5.9 times 10 to the 4th. Did I copy it wrong? So we can change this to standard form, so I guess that's what I would do. So 9 to the 5th, sorry, 9.5 times 10 to the 5th, move it 1, 2, 3, 4, 5. That is 950,000. 5.9, 10 to the 4th, we move 1, 2, 3, 4. That is 59,000. So if you add these two, we get 1,009,000. Is that it? 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1,009,000. 1 Okay, and then if you change this back to scientific notation now, it's going to be, well, the decimal's at the end, so it's going to move 1, 2, 3, 4, 5, 6. So 1.009 times 10 to the 6th power, and we get, oh, look at that, E. Oh, and this was 14. I keep forgetting to write the number. We done? No, 15. 15. 7.56 times 10 to the third. Move the decimal 3 places over to the right. 1, 2, 3. So it's 7,560. 16. 6.8 times 10 to the negative 1 in standard form. So here's 6.8. We're going to go left. So it's just going to be 0.68. That's it. 17. 1.2 times 10 to the negative 3 times 6 times 10 to the 5th in standard form. So let's multiply our first factors in each. So 1.2 times 6, that's a 12 carrying 1, so that's 7.2. Now we're multiplying, so think about this. Go back to your laws of exponents. Bases are the same. We add the exponents, so that ends up being 10 to the 2nd. So, and that's our answer. Okay. No, well, actually that's not our answer because we want this in standard form. So now I change it to standard form, so 7.2. It's 10 to the 2nd, so let's multiply, which is basically multiplying by 100. So we move the decimal 2 over, 1, 2, so that final answer is 720. Yikes. 18. What is the value of 3 times 10 to the 5th? 6 times 10 to the 2nd. Well, in standard form. So let's simplify as best as we can. So 3 over 6 is 0.5. Right? And 10 to the 5th power divided by 10 to the 2nd is times 10 to the 3rd, right? Remember, it's 10 times 10, 5 times on the top, and then 10 times 10 at the bottom. And if you simplify, you're going to be left with 10 to the 3rd power. So now we got to change this to standard form. So this is the same as saying, what is 0.5 times 1,000? Move the decimal 3 spaces over, and we get 500. 19. Okay, and the distance from Ben's to the library. How much further is Ben's house from school than, okay, so 4.6 times 10 to the 3rd. Okay, this is from home to school. So home to school. Let's write it in standard notation. We're going to move the decimal 3 over. 1, 2, 3. So it's 4,600 meters. And then from home to the library, it's 6.4 times 10 to the 2nd power. So it's 6.4 times 100, which means we move the decimal 2 times, and we get 640. If we subtract these two, we get 3,960. Okay, so let's go back. I'll do one more section for this video so that it doesn't get too long. What is next? Counting principle. Where is the counting? Oh, it's right next, the next section. Okay, that's easy. Let me change the title. I wonder if they meant it's. Oh, no. 72. Counting principle. away. So that's not too many questions. So I'm looking at 20. So number 1, cleaning and storage room. They take turns working. Well, how many different teams can they make? How many different teams can they make? So we have 4 people. We have A, B, C, D. So the one thing you have to understand is that order is not important here, right? Because I guess AB is the same thing as BA, so Alex and Bia would be the same thing as Bia and Alex. Okay, so this would be a combination, right? So if you remember, if it's, I wonder if it's easier to do this. So we can go A and B, A and C. Let me try A and D. B and A is already done, but B and C is not. B and D is here, right? Because B and A we're already done. B and D is okay. C and A is already done. C and B is not. No, C and B it is. And C and D has not been done. And then with D, D and A has been done, D and B has been done, and D and C. So we have 1, 2, 3, 4, 5, 6. I wonder if that's easier, okay, than what do you call that formula, the formula for combinations. Okay, I would, if it's only 2, or what it is, if it's only 4, like it's written here, maybe it's, if you did a combination, oh my god, I have to look at it. It'd be in this case 4 people taken 2 at a time. So it would have been 4 factorial over 2 factorial, and then 4 minus 2, so it would be 2 factorial. So 4 factorial is 4 times 3 times 2 times 1. 2 factorial is 2 times 1, and 2 factorial again is 2 times 1. Let's simplify, and you get 6 either way. Right, so it's really up to you. Number 2, Tony has 6 card lying on the table with the numbers 1, 1, 2, 2. How many different 2-digit numbers can be made by placing a pair of cards side by side? Okay. There's 1, 1, 1, 1, 2, 2, 3. So we can do, we have a 1, sorry, a 1, a 1, and a 1, a 2, a 2, and a 3. Well, can we do 11? How many different ones did they say? Okay, yeah. So this one, so can we do 11? Yes, we can. Can we do 12? Yes, we can. Can we do 13? Yes, we can. Can we do 21? Yes, we can. Can we do 22? That's possible. Can I do 23? That's also possible. Can I do 31? Yes, I can. Can I do 32? Yes, I can. And I think that's it. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah, answer is G. 3. Baking 3-layer cake. She has 3 choices for each layer. And each layer must be a different color. How many different ways are there to, so she has 3 layers. For this one, on the first layer, she has 3 choices. So you can use a fundamental count principle. The second layer, obviously, if 1 is used, you now have 2 choices. And the last layer is whatever's left over. So there's a total of 6 different. Is there 6? Yeah. So 3 is B. Number 3 is B. Okay. 4 is lining up 5 students in a row for a class photo. The shortest student will stand in the middle. Oh my God. Shortest, let me write short guy in the middle. The next 2 taller on his left. The next 2 tallest on his left. How many different ways can the 5 students be lined up? What the heck? Okay, so that's the shortest. The next 2 tallest on his left. Okay, so I guess it would be tallest, tall, second tallest. And I'll do it like this. That's the shortest, and then third tallest and fourth tallest. Okay. Let's change this and call them. So if we let's better if we call them A, B, C, D, and E. Right. So if we have this one, so C will always be in the middle, no matter what. So we can have A, B, C, D, E. We can have A, B, C, E, D. Right. Change that. I can't have anything else. And then what if I change A, B to, I can have BA with a C and then a D and a E. And I can have BA with a C and an E and a D. So that's the only, can't think of any other different ones, right? Because these two guys will always stay on this side. This is number 4, right? See, A and B will always be on the left side. D and E will always be on the right side. So they won't switch sides. So the only, right? So the only, and C will always be in the middle. So D and E can only become E and D. Right, they can't go to the other side of C, and A and B can only become A and B. So 1, 2, 3, 4. Yeah, 4 choices. 5. Let's see. 5. 10 different shirts, 4 different pair of pants. How many different outfits? Well, this one is, right, this one is the number of choices times the number of choices in the second. So it's 10 different shirts times 4, which equals 40, and that's C. That was a little bit simpler. 6. The menu at a fast casual restaurant offers 9 different types of soups. How many different? Okay, again, so we have 9 choices for soups, 6 different choices for salads, so we get 54. Okay. 7. Create a code. It must be 3 characters long. 1, 2, 3. For each character, he may choose all 10 digits, 0.9. He may be repeated. So for here, you can choose anything from 0 to 9, so he has 10 choices. From the second one, it can be repeated, so 0 to 9. And the third one can be 0 to 9, so we have 1,000 different, combinations that can be made. Okay. 8. Choosing a password for his phone using the letters of the alphabet. So password must be 4 letters long. He can repeat the letters. How many different passwords? So it's, again, the same as the previous column. 26 choices, 26 choices, 26 choices, 26 choices, which leaves us with 26 to the 4th power, which is G. Number 9, again, this, you can use a fundamental counting principle, right? Counting principle, which says that you can multiply the number of choices in one category times the number of choices in the other category, times the number of choices, etc., in each category to get the total number of possibilities. So deli offers 3 kinds of bread, 4 kinds of deli meat, and 3 types of cheese. So how many different sandwiches can you make? For the breast, you have 3 choices. For the meat, you have 4, and for the cheese, you have 3. So this would be 12 times 3, which is 36 different types of sandwiches can be made. Okay. 10. Multiple choice quiz. Again, same thing, has 3 questions. So question 1, question 2, question 3. So first, and each of the questions has 4 choices. So for question 1, I can choose A, B, C, or D. So I have 4 choices. Question 2, I have A, B, C, D, A, B, C, or D. So that's 4 choices. 1 to 10th is 4 choices. Well, that gives us 4 to the 3rd power, which I believe is 64. 11. She's ordering a custom license plate. It must be 6 characters. 1, 2, 3, 4, 5, 6. For the first 3, he may choose any letter from A through Z. Does it say can be repeated? And he may choose any digit. So it doesn't say anything about not repeating. So we have 26 times 26 times 26. And the license plate is going to be 10 times 10 times 10. Do we have anything like that? Yeah, we have 26 to the 3rd power times 10 to the 3rd power, which makes this 8. Okay. 12, another code, 1, 2, 3. You may not repeat digits, so it's a little bit different. So again, 0 to 9. In the first try, you can use any of the digits. But the second try, 1 was used, so that leaves me with 9. This is 12. And the third try, third digit, 2 of them has used, so that leaves him with 8 choices. So this is 720 possibilities. Okay. 13. So this one is a permutation because order does matter. When they're competing for gold, silver, and bronze medal, how many different ways can they place? So we have 5 swimmers, and we want to know in 3 different positions how many ways can 5 swimmers come in 3 different ways. So we can use, in here we have 5 choices, here we have 4 choices, and here we have 3 choices. And that's going to be 60. So the final answer is B. Okay. 14. Gail's choosing a password for her phone. It must be 4 letters long. She cannot repeat the letters. So erase this. So for 14, if you can't repeat the letters, it has to be 4 letters long. So the first choice you have 26. The second you have 25. The third you have 24. And the fourth you have 23. So whatever that is, and we have, thank God they didn't multiply. Final answer is H. Okay. 15. Where's 15? Down here. 15. Again, another license plate. So 15 is the license plate question. 1, 2, 3, 4, 5, 6. You may choose any letter A through Z for each of the first 3 characters. But no letter or digit can be repeated. How many different license plates? So the first 3 are letters, right? So it's going to be 26 times 25 times 24, and then 10 times 9 times 8. So this is letter D, right? Because it's 26 times 25 times 24 times 10 times 9 times 8. Okay, 16. 7 different books. She's going to arrange 3 of them on the shelf above her desk. In how many different ways can she arrange 3 books? So does order matter here? Well, if she has 7 books, A, B, C, D, E, and F, and A, B, C, is A, B, C different than C, B, A? Right? is different, right? So does it say here? In how many different ways can she arrange the 3 books? So again, here we can just use a fundamental counter here. So on the first spot in her shelf, she has 7 choices. Second spot, she has 6 choices. And then 5, 6 times 5 is 30, 30 times 7 is 210. 17 has not a multiple choice, so again, let's go back to that, the deli sandwich question. So 17, 1, 2, 3 things, 3 kinds of bread, 5 kinds of meat, and 3 types of condiments. So that's just 30 different types of 3 kinds of bread. Sorry, 5 times 3 is 45, not 30. Okay, 45 different sandwiches you can make here. 18, in a math competition, the first place winner gets 100, second gets 50, and third gets 25. 10 people can compete. In how many ways can the first, second, and third place finishers be decided? So again, you can use a fundamental counting principle. So we have first place, 10 people can come. If one of them is already in first, we have 9 people left. And likewise, for third place, we're only going to have 8 people left. So it's going to be 10 times 9 times 8, which is 720. Number 19. Simone has 3 shirts, 3 skirts, 3 belts. How many different outfits can she make if she doesn't want all 3 items to be in the same color? Wait a second. What does that mean? Not in the same color. Let's see. So we have 3 choices for shirts, 3 choices for skirts, and 3 choices for belts. She can make 27 outfits with outfits. How many different outfits can she create? She doesn't want all 3 items to be the same colors. So out of the 27 outfits, there's one set that can be, let's see, red, yellow, blue. There's one set that can be red, red, red. Red shirt, red skirt, red belt. There's another set that can be yellow shirt, yellow skirt, and yellow belt. And there's one more that can be blue shirt, blue skirt, and blue belt. So out of this 27 outfits that she can make, 3 of them, are the same color. So we have to subtract those 3. So she can actually make 24 unique outfits. Okay, because not unique, but that are not all the same color. Okay. Tricky. 20. Social studies class imagines that the United States creates a 51st state and needs a 2-letter state abbreviation like California. CA for California. The class can use any letter in the alphabet. They can repeat letters, but they cannot use an abbreviation that's already being used by one of the 15 existing states. How many different abbreviations can the class create? Oh my God. So it's like the previous question. So there's 26 choices here, which means there's 25 choices here. So assuming, can we repeat? Oh, we can repeat. I'm sorry. So it's 26 times 26. So this is number 20. So the class would have 26 choices for the first letter and 26 choices for the second letter, giving you a total of, I have no idea, 6 times 26 is 676. So 676 choices. But it says you can't use the abbreviations that are already used. So she can't use, for example, New York, NY, New Jersey, FL for Florida, California, whatever else. Vermont, I think, is VT. Georgia. Right, so she can use the ones that are already in use. And how many do we already have in use? We already have 50 that are in use. So out of the 676, you have to subtract 50 that are already in use, right? Because we have, and that leaves the class with a choice of 626 letter combinations for the new 54 state. Okay, that's it for this video.